All right, so looking at A, if we have a look at the base case, which is 1, let's just prove it is true. So we could say P of 1 is true since, and we know the left-hand side here is 1 squared, which is 1, and that's greater than the right. I'd do this separately. 3 minus 2, which is 1, so it all works. So I would have said, sorry, left-hand side equals 1 squared, which equals 1, and right-hand side equals 3 lots of 1's minus 2, which is 1, and 1 is equal to 1. Well, I could even say it's greater or equal to 1. So it's true for the base case, and then so we're going to assume it's true for P of k, so we're assuming that k squared is greater or equal to 3k minus 2, and we want to prove it's true for k plus 1, so we want to prove that this 3k plus 1 minus 2, that is true. Alright, so if we did start just at the left hand side, of course you can do this in very many different ways, for example left hand minus right hand side, but if you want to keep just the little left hand side, that's okay too. So if we've got k plus 1 squared, we just know we want to use k squared somewhere, so it's okay. So there's k squared there, and it's 2k plus 1. So if we're going to sub something smaller in than k squared, which we are, 3k minus 2 in there, then we can put that inequality in. Now if you look at that, what are we getting? We're getting the 3k, so if I just look at this side for a second, you can see it's, if I expand it as 3k plus 3 minus 2. So I'm getting the 3k and the minus 2, and then the rest, I just have to show the rest is greater than or equal to 3k, what am I doing? Sorry. So I've got this, then greater or equal to 3. So this is the bit that I've got extra, but I want it to be, you know, equal to plus 3. So I'm going to compare 2k plus 1 to 3. Now if you think about it, our base case is 1. So if I put 1 in this, you know, that's our base case. So it could be 2, it could be 3, etc. So this is always going to be, and if I put 1 in, I get a 3. So that side is always going to be greater than or equal to 3, since k is greater or equal to 1. So I could say here, but 2 to the k plus 1 is greater than 3, so I'm going up here, since k is greater or equal to 1. So therefore this line above is greater or equal to 3k minus 2 plus 3, which is what I want, because I want, and I'll just kind of really show it, I want it to look like that right hand side, which now it does. So now that's equal to the right hand side. So we can say therefore, and we've got that line, k plus 1 squared is greater or equal to 3 k plus 1 minus 2, no problem. And that's, you know, so P of k is implying P of k plus 1, and therefore it's true for all n is greater or equal to 1.